Hi guys, so today we are solving this problem called maximum candies allocated to k children. Let's read it. You are given a zero index integer array candies. Each element in the array denotes a pile of candies of size candies of I. You can divide each pile into any number of subpiles, but you cannot merge two piles together. You're also given an integer k. You should allocate piles of candies to k children such that each child gets the same number of candies. Each children can be allocated candies from only one pile of candies, and some pile of candies may go unused. Return the maximum number of candies each child can get. Right. So we've been given this candies arrays, and all these values represent the number of candies each uh, you know index holds. And we've been given k, which denotes the number of children we have. So we have three children here, right? And we have three set of candies, and we need to basically give these three children the same number of candies, and that should be maximum, right? So in this case, if we give five candies, so first index can give five candies, then the second index we can actually divide it into five and then three, right? So five candies can be extracted from it. The sixth and the third index can actually also give five candies, right? And it can be divided into five and one, right? So it is possible to give five candies, maximum five candies in this. If we go ahead and do for six, right? So obviously, like six candies can't be given for this one, candies can't be given for this one, six candies can be given for this one. So we have just two candies to be given to like two children who have six candies, and the third one will not get equal candy number, right? So that is the idea for this question. How we'll solve it is pretty simple. We know that the maximum candy can be the maximum number in that array, right? So maximum number in that array will be basically the maximum possible candy, right? So in this case, it is 8. So 8 is the maximum possible candy, right? Now, if I know that if 8 is the maximum possible candy, I can go from 0 to 8 and try each and every combination until the time I'm able to separate out k candies in k children, and they must be equal, right? So if I go from 0 to 8 one by one, right, and I check if one candy can be given to three children equally from this set, right? And then two candies can be given from this set equally to all the children, right? So that will be the idea. So if I go from 0 to 8, right, and I just keep on picking numbers and I try to see what is the maximum possible number of candies that I can give from this set, then that would be my answer, right? So which will require O of n, right? But we know that it's going to be always from 0 to maximum number of candy, right? It's going to be sorted, right? So we can apply binary search, which will be giving us log of n, right? Time complexity for it. So if I just go from 0 to 8 and I go to the mid, which is basically um 4, right? At 4, I will, you know, I'll check if four candies are possible in this set or not. If it is possible, then I will go ahead and, mark this as obviously like, that is the maximum number of possible candies that can be spread across the children. And I'll start from that. The low will start from that mid, and it will go till the end, right? High will be basically the highest value here. So basically, I will just go and make this as the maximum number of possible candies, and I'll iterate to the right of it and try to get the maximum number of candies there. And if it's possible, then I just do it again, low equal to mid. Otherwise, I move the high pointer, which is mid minus 1, right? And I try to check if it's possible to, spread out the candies. So that would be my approach. Let's get to the coding part in order to understand this a bit better. Let's get to the coding part. So first of all, I'll want to know the maximum candies possible in this array, right? So candy in candies, I'll just iterate and I'll say maximum candy is equal to max of candy and max candies, right? And after that, I'll check that low is 0 and high is basically max candies, right? And I'll have a while loop, which will be basically my binary search. While low is less than high, I'll find the mid, which is low plus high plus 1 by mid by 2, right? That will be my mid. Now I'll check if it is possible to can allocate candies. I'll create a function where I'll pass basically the candies array and I'll pass the mid, and yeah, that should be it, right? And I'll just do low equal to mid if that's possible. Else, if it's not possible, then I'll do right equal to I equal to mid minus 1, right? And in the end, I'll just return the low, right? In this cell can allocate function that we'll create, we are just going to iterate through the array and check if it's possible to, you know, put the candies, right? So number of candies. So in that case, I'll also pass the k value here because I need to know that how many children are there. So max allocation equal to 0, and I'll just iterate through the pile in candies basically, where I'll check max allocation equal to max allocation plus pile by number of candies, right? That is the idea. And yeah, total number of that max allocation plus pile of candies, right? Whatever it is possible. In the end, I'll just check if the max allocation, if it's greater than equal to k, which means that it's equally spread into all the children, then I'll return true, otherwise I'll return false, right? So that is the idea. Let's run it to see if everything is working fine. That works. Cool. I hope you guys understood the problem. Thank you so much.